Hello guys, in this class we are going to learn a new technique to be able to solve the second order differential equations. As you know, we have learned before the undetermined coefficient technique, so we have a lot of information, we have a lot of experience about it, right? Today, it is a new technique we call the variation of parameters. It is totally a new technique, and then it has nothing to do with the undetermined coefficient method. So again, this is our enemy, if you remember from the class, right? And as you know, this is a non-homogeneous equation. It might be homogeneous as well, but it is a non-homogeneous equation. And then this time, look at that. We have a function. I can have another function on the right-hand side. Look at that, something like that. And also look at that. Let me give you another example. E to the t over t squared plus 1, right? If you remember the undetermined coefficient technique, there is no solution technique, right, we can use to be able to solve this type of function if I have on the right-hand side. So this is why, okay, we're going to require to have a new solution. Okay, so since all the undetermined coefficient technique will work, right, for the elementary function when you have the cosine, sine, exponential, or the polynomial type of functions. So what are we going to do? We're going to start by the homogeneous equation solution. You will remember, right? This was the homogeneous part of the solution. We had, right, the two linearly independent solution. Then we need to combine them linearly by multiplying the coefficients. We're going to assume, okay, we have the similar type of particular solution to our differential equation. The only difference will be the parameters. Okay, look at that. I will be using, instead of the coefficient, in my homogeneous part of the solution. So what I did, look at that, I just changed the C1 to the V1, right? And C2 to the V2. Okay. I just assume, okay, we have this type of solution. And I will try to see, okay, if there is such a solution. To do that, as you see, right, I don't have any idea about the V1 and the V2. That is why, okay, we need to find them out. We need to find a way how I can figure out what these new parameters are. So the basic question, okay, will be this one. So I need to figure out what is V1 and then what is V2. Since this is just the assumption, I don't know if it is going to work. As I always did, right? So when I assume a solution for my differential equation, I always followed my differential equation. And then I will do the same thing, look at that. What I will do, I'm going to take the first derivative of my assumed solution. So, as you see, this is a product. That's why I need to apply the product rule. V1 prime times y1 plus V2 prime times y2 plus, look at that, V1 times y1 prime, and then plus V2 times y2 prime. I'd like to keep them separate since I'm going to use some other algebraic technique to simplify my job, okay? That's why I wrote in this way. I took the first term derivative, as you see, V1 prime, and then multiplied by the second term. Okay. But as you see, I have four terms here, right? And then I also have the derivatives around, and then also the derivatives of V1 and then V2. And I am gonna need, the yp second prime for my differential equation. But if I take the second derivative, there's gonna be mass around, right? Even though I don't know what the V1 and the V2, if I deal with, V1 second prime, V2 second prime, it's going to be hard to find them out. This is why, okay, at this step, I'm going to make another assumption, guys. So what's going to be this assumption? This assumption is going to be about this part. Look at that. This part, okay, to simplify my job, I will assume, okay, this will be 0, okay? Of course, assuming, okay, this part is going to make the solution space limited to the functions, okay, which satisfies this condition, but at least, okay, I'm gonna have simpler job to complete this process. Okay. Now, I can go ahead and then I can take the second derivative of my solution. If I take this second derivative of the terms left, right, it is gonna be this way. Look at it, I'm gonna apply the product rule again. And if I apply the product rule, I need to take the derivative of the y1 prime second prime and then also look at that and then y2 second prime. Great. As you know, now what I need to do, right, I need to multiply by the coefficients. Coefficients, I mean ay second prime, by prime plus cy, which is equal, right? Now I'm going to multiply a times, I have the yp second prime here. I'm going to multiply all the terms by a. v1 prime times y1 prime and plus v2 prime times y2 prime and plus v1 y1 second prime plus v2 y2 second prime. And I had the y prime terms, I need to multiply by b times, right, I have left by these terms, if you remember, right, yeah, v1 times y1 prime plus, and then v2 times y2 prime. And then also I have the y term there, which I need to multiply by c. So it's going to be v1 times y1 plus v2 times y2. Okay, now, as you see, I have a big, a lot of terms around, so I need to be able to cancel some of them. To do that, look at that first. I'm going to try to group all these terms by looking at, right, what are the common terms here. If you look at, okay, these terms, look at that I have the common terms v1 are all around. And then if you look at one more time, right, you can see the v2s are going to be all around. Okay. Now I can group them. Okay, I chose the wrong pen, guys. Just bear with me. Let me group them. So I will have this, right? It's gonna create another equation for me. You will notice later. Okay, and so v1 parentheses, right? v1 is gonna be common term, and then I can have all these terms. y1 second prime plus b y1 prime plus c y1. And look at that, v1 a y2 second prime plus b y2 prime plus c y. Okay, please think one moment. What do you notice in this equation? If you remember, right, y1 and then y2 were the solution for the homogeneous equation, right? That is why what I can say here, right, these two terms are going to be 0, right? These are 0 terms. Look at that. These are 0 terms, correct? Then what I have left is going to be this one. A times v1 prime, y1 prime plus v2 prime, y2 prime, and that's it, right? And then on the right hand side, sorry, I have the f of t. Great. Look at that. I obtained another equation besides the assumptions I did at the beginning, right? You will remember that was a 0. So look at it, I have two equations. The first one, this one, let me write this one first, right? If I divide it by a, both sides, I will have this one, v1 prime, y1 prime plus v2 prime, y2 prime, which is going to be equal f of t over a. And I'm going to name this one equation 1. And equation 2, guys, remember, right? I assumed that was 0. You see now, what I got two equations which includes, right, the v1 prime and then v2 prime, correct? Look at that. v1 prime here, I have the v1 prime and then v2 prime and then v2 prime. So there is a chance here, right? So I can solve, right, what v1 prime and then v2 prime, then maybe I can integrate them to find the v1 and then v2. That was my aim. Okay, I'm gonna try it, since this is a linear system, and then I know how to solve it, right? So I can try. Either you can use the substitution or the elimination. Let me use, right, the equation 2 first, right? From the equation 2, I can get the v1 prime is equal to v2 prime y2 over y1. And then if I substitute this, right, into the first one, what I would get negative v2 prime times y2 times y1 prime over y1 plus v2 prime and then y2 prime, which is equal f of t over a. So if you notice again, right, I have what? v2 prime's terms are common. Which is why it is possible to pull this out, right? If I pull the v2 prime out, look at that. Here I have two rational terms, right? Two terms. I can make their denominator same by just multiplying y1. If I do this, I would have this one. y1 times y2 prime minus y2 times y1 prime and over y1, which is equal f of t over a. And from this, v2 prime is going to be equal y1 times f of t over a times y1 times y2 prime minus y2 times y1 prime. Okay, did you see that? I found what the v2 prime is, and to be able to find what the v2 is, you can just integrate what you have here. So v2 is going to be equal integral of y1 times f of t over a times whatever you have right inside the parentheses dt. So that's great, right? I found a way how to figure out what the v2 is. If you do the same thing for v1, you are going to find out this one. Negative y2 times f of t and a times whatever you have in the parentheses dt. Okay, guys. As you see, I found a way, right, how to find out the v1 and then v2. That was my purpose. And then that is what I call, right, the variational parameters technique. So now we are ready to solve some examples about this technique, using this technique, but I just want to add a couple of things. The first thing, right, please don't memorize these formulas. But if you want to use these formulas, you can still use, okay, but you need to pay the price of memorizing. Since when you solve, okay, this type of equation, the process is going to stay same, and then you're going to find out how to solve the v1 and the v2, just solving the linear system of equation. The second thing, in your book or in some other places, you may look at it, okay, they call, okay, the parentheses, which I left blank here, they call these parentheses the Wronskian matrix of, right, these two solutions. And then the Wronskian matrix is equal y1 times y2 prime minus y2 times y1 prime. Okay, so now I'm going to finish this lesson here, and in the next lesson we're going to start solving some examples, okay, using the variational parameters. See you in the next class, guys.